Okay, we have a series. It's not just any series, it's an alternating series. We could tell because we have negative n to the power of n. With an alternating series, we tend to do an alternating series test, first of all. So the alternating series test has two conditions that we have to meet. And if we meet those two conditions, then we can say that this converges. So the first condition is that b sub n plus 1 is less than b sub n. And we also have to make sure that, so in other words, that this is monotonically decreasing. B sub n would be the portion without the alternating portion. So b sub n here would be n to the n over n factorial. And then b sub n plus 1 would be wherever we plug n plus 1. Alternatively, to find out if it's decreasing, we could take the derivative of b sub n and find out if that's negative for most of its behavior. Because we're really just considering infinity, so even if the first few terms aren't negative, but the rest of them are, then that's good enough, and it passes the first part of the test. The second part of the test is that if we take the limit as n approaches infinity of b sub n, that this must equal 0. If both of these tests are passed, then it converges. Otherwise, you can't tell if it converges or diverges because it failed some part of the test, and then you have to do some other test. For example, just a divergence test, and check if it diverges or converges. So only if it passes both tests can you be sure that it converges. Otherwise, you can't tell if it diverges. You would have to do another test. So let's do that. Let's first check with the alternating series. Is this b sub n always less? Is it becoming less with each passing term, is what I mean. So we have to check what that means. What is n to the power of n? N to the power of 2 would be n times n, right? So n to the power of n just means n times n times n times n times n forever. Forever. It's just going to go on forever. N factorial, what that means is that you have n, and then you multiply that by n minus 1, and then you multiply that by n minus 2, and then you multiply that, so on, n minus 3, n minus 4, until you get to 1. Until you finally get to multiplying by 3, multiplying by 2, and multiplying by 1. That's what n factorial means. So, knowing that, now we know that this denominator is smaller. It has to be smaller than the numerator because the numerator is just multiplying n's. So no matter what value we have for n, the numerator is obviously going to be larger than something which has smaller values each time we multiply. So this is obviously not decreasing. It's not decreasing, it's actually increasing with each further term because the numerator is greater than the denominator. So knowing that, now we can forget all about this. We don't even have to take the limit as n approaches infinity because it already failed the first part of the alternating series test. We have to do some other test. Another test we could do is the divergence test, which should be like our first gut reaction after having failed that. Then we think, hey, maybe it diverges. So we do our divergence test in which we take the limit as n approaches infinity of the entire thing. Remember, with the divergence test, that's from earlier chapters, we do the entire thing. It's not just b sub n. So this would be negative 1 to the power of n, and then we have n to the power of n factorial. With this one, we already know that this is going to diverge. We know that this is going to diverge because if we plug in numbers here, We'd go 1 and it would be negative. We'd plug in 2, it would be positive. 3, it would be negative again. And so we never settle upon positive or negative. Infinity never settles its mind. It just keeps rolling on the tape and switching and switching and switching between negative and positive. So we never know where it goes. So it doesn't even matter what we have over there, really. We know that this is going to, this limit is not going to exist. It doesn't exist. Therefore, our series diverges. Because the definition of divergence is that it either goes to infinity or that the limit doesn't exist.